Hello friends, so I'm gonna solve this problem all ancestor of a node in a directed acyclic graph. So what is happening is one directed acyclic graph is given to us and we have to find the list of all ancestors of each and every node. Okay, so for example here you can see 0, 1 and 2, it doesn't have any ancestor, right? So their values is null. But if you look at 3 has 0 and 1 ancestor, 4 has 2 as ancestor, right? So similarly we have to find the ancestors of each and every node. So 0 and 2 are the ancestor of 4. Similarly we have to find all the ancestors of every node. So let me explain this thing with the diagram. So now I'm making the adjacency list of this graph. Okay, so see here 0 is connected to 3 and 4. Similarly 1 is connected to 3 and yeah, so 1 would be only connected to 3. So similarly we have to make the adjacency list for all of them. So see here 2 is connected to 4 and 7. So 2 would be having the list of 4 and 7. Okay, so similarly it would be entirely we have to complete the adjacency list. So see here I have completed the adjacency list. If you look at here 5, 6 and 7, they are not connected, means that nothing is going outward from them. So they have adjacency list. 5 has empty, 6 doesn't have anything, 7 doesn't have anything. So 5, 6, 7, they are not connected to anybody, right? So they have the null. Otherwise 3 is connected to like 5, 6 and 7, 4 is connected to only 6. So we have completed adjacency list first of all. Then we have to make the Indegree of this entire graph. Okay, so we have to create an Indegree array of size n, and then we will populate the Indegree of each and every node. So I created this Indegree array. Now we will fill the Indegree of all of them. So 0, no arrow is coming towards 0, so its Indegree would be 0. Similarly for 1 also it is 0, for 2 also it is 0 only. For 3 it is, how many incoming nodes are there? 1 and 2. So two arrows are coming towards 3, so it has Indegree equal to 2. 4 also has 2. How about 5? 5 also, 5 has only 1. 6 has 2 and 7 also has 2. Okay, so we have initially filled all the Indegrees. Now our next task is we will create a queue and all those nodes which has Indegree 0, okay, like this, we will put them into queue because those guys don't have any ancestor, they are not dependent on anybody. So we are proceeding from there. So we will create a queue and put all those guys having 0 Indegree into the queue initially. So I just created the queue. So who all will go to here? 0, 1 and 2. Okay, so all of them has Indegree. So 0 has Indegree 0, 1 also has 0, 2 also has the 0. So initially 0, 1 and 2 would be inside queue. Now we will pop out the value one by one. So let's bring out 0 first. Okay, so we are done. We are gonna take 0 first. So we took 0 here out. Now see here, when we are so if we remove this 0, what will happen? Whoever is connected directly to 0, their degree would be decreased by 1, right? So if I delete 0, then these two arrows also would be deleted, right? That means 3 and 4 degree would be decreased by 1. Okay, so similarly you can check here. So go to adjacency list, check who all are connected. So 3 and 4 are connected, so we have to decrease the degree by 1. So 3 has 2, so now what it would be? It would be new value will become 1. Similarly for 4 also it is 2, so 2 minus 1, so new value of Indegree would be 1. Okay, now we are done with the 0. So 0 would be come out of it. Now we will go to next value, which is 1. So let's take the 1 out of it. Now see here, with whom 1 is connected? 1 is connected to 3 only. So what is the Indegree of 3? It is 1. So we have to decrease by 1. So it would become now 1 minus 1 equal to 0. Okay, so new value would be 0. And as soon as something becomes 0, we have to put those values also into queue. So 3, because its degree now becomes 0, so we have to put that also into the queue. So I am bringing this 3 into the queue. Now we are done with the 1. So next value what? It is 2. Okay, so come to the 2. So who all are connected with the 2? So for 2, 4 and 7 are connected. 4 and 7. Okay, so we have to go to 4. So we have to decrease by 1. So 4, it is 1. So 1 minus 1 is equal to 0. So let me make it 0. And because it is becoming 0, we have to immediately put that guy also into Q. Okay, similarly 4 is done. Then we have 7 also connected with the 2 only. So 7, what is the Indegree of 7? It is right now 2. So we have to decrease by 1. Okay, so it will become 1. So it is not 0. So 7 will not come to the Q. Okay, so we are done with the 2 as well. Now we will come to 3. Okay, so see 3. With whom 3 is connected? 3 is connected with 5, 6 and 7. Okay, so 5, 6 and 7. We have to decrease the degree by 1. So if we decrease degree of 5, it will become 0. So we have to bring this guy also into Q. Okay, now we will go to 5 is done. We will go to 6. So 6 has what is in degree? It is 2. So new value would be 1. So because it is not 0, so 6 would be stay there only. Now we will come to 7. Its in degree is 1. But 1 minus 1, it will become 0. And because it is become 0, so 7 also will come to the Q. Okay, now we are done with the 3 as well. Okay, so we will keep this 3 here. Now we are coming to 4. Okay, so see here 4, with whom 4 is connected? 4 is connected to 6. So we will go to 6. 6 in degrees, right now it is 1. So we have to decrease by 1. So 1 minus 1 equal to 0. Now 6 is also becoming 0. So we have to bring 6 also to Q. Okay, so we are done with the 4 also. Okay, now we will come to 5. Because 5 is not connected to anybody, so we will come directly as it is. Similarly for 7 also we are directly connected. So 7 doesn't have any degree. So now finally we have this 6. Okay, 6 is also not connected to anybody. So this is our topological order which we just got. Now this topological order we will use to find the ancestor of all these nodes. I'll tell you how we will do it. So now we will traverse through this topological list, okay, which we just got. Okay, so what we have to do is first of all we will come to this first one, right? This is 0. So in adjacency list we will look 3 and 4, right? 3 and 4 are the one which are directly connected to 0. So first of all we will go to 3 and 4. Okay, this is our 3 and this is our 4. In this point, so for 3 and 4 we have to directly add the 0, right? Because we are coming from 0. So 0 and whatever the ancestor list the 0 has. So 0 don't have anything, right? So 0 and 0 is only that is included here. Now we will come to this point. Okay, 1. So we will go here. So 1 is connected to 3 only. So we will go to 3. First of all we will add 1 here, plus the adjacency, whatever 1 has the answer list of 1. So 1 has also nothing, right? Because these guys are starting as a 0 in degree. So here also we wouldn't add anything. Now we will come to this 2. Okay, so what is there in 2? 2 has 4 and 7. So we will go to 4 and 7. First of all we will add 2 here. So I added 2 here. Similarly for 7 also we will add 2 here. And then we will check what is there at 2's list. So 2 list doesn't have anything, so we will proceed ahead. Now we will go to 3. Okay, so 3 is connected to whom? 3 is connected to 5, 6 and 7. Okay, so for 5, 6 and 7 we have to add, first of all we have to add 3. Okay, so 3 would be there in this list, similarly here also, and similarly here also. Now we will check what all values are there in 3. So 3 has 0 and 1 already. So other than this we have to add 0 and 1 as well. Okay, so we have to take care that duplicate should not come. So 0 and 1 we will add here, 0 and 1 we will add here as well, and similarly 0 and 1 would be added here also. Okay, so now we will go to 4. Okay, so what is 4 having? 4 having 6. So we will go to 6 and we will directly add 4 here. Now we will check what is there at 4 list. So 0 and 2 is there, but 0 we have already added, so only 2 would be added here. So I have added 2 also. Now we will go to 5. Okay, so see here 5. With whom 5 is connected? No one, right? So 5 is not connected to anybody, so we will not add for anything. Similarly for 7 and 6 as well, they will not be the ancestor of anybody. So finally we have, this is the list that we have to have. So we can confirm it with the diagram also. See, we can confirm this. See here 0, 1, 2, obviously they don't have. 3 has 0, 1, 4 has 0, 2. So let me go to this thing. See here, we can clearly check it. See, these guys doesn't have any ancestor, right? 3 has 0, 1, 4 has 0, 2, right? And similarly check for 5. So 5 has 3, 0, 1, right? And 6 has more, all of them, all these guys are the ancestor of 6. Similarly for 7 also. So you can double check it here. We are getting the same result. So this list we have to return as our answer. Now I will walk through my code. So I will explain each and every line here. So this is my adjacency list which I just declared, and these are my final result variable, and this is my result set variable, because I am creating this set thing so that I can take care of the duplicate values. Okay, so for that reason, because we have to escape the duplicate values in our final answer, right? So after creating these variables, first of all what I am doing here is I'm just creating and populating some values to adjacency as well as this resultant and these two variables, right? So now I have created here the Indegree array, and here I am populating the Indegree of using the adds array, right? So if we make the Indegree of second value, right? See here, if we make this guy plus plus, then Indegree would be increased for every ages, right? And similarly I am populating my adjacency list also, because 0 is the one, D0 is the one where from we are starting, and it is going to D1, right? So from to 2, so adjacency is also populated here. Then I'm creating one queue here, and here I'm checking that what all values are 0. So whoever has value 0, I'm adding that index to queue. Okay, this is what we were explaining. Now after doing this, so here I'm just making one check that if nothing is went to queue, that means there is no node which has a 0 in degree. So in that case we have to return. Then I'm creating one array list where I can park my top topological order, right? The one which we were just found, this one, right? For this one I am just creating an array list so that I can park these values. And then here I am checking in the queue. So while queue is not empty, I am just popping out the values. I am putting into the top order this array list, right? Topological order. And then I am checking that whose Indegree is gonna decrease, right? So we are going to the adjacency list of this item, right? And we are decreasing the Indegree, because whenever we were removing a parent, all the Indegree of their child were decreasing. And if after decreasing, if any degree is becoming 0, I am putting that into queue. Okay, just this for the sake of print, I just put it here. Then what we are doing is finally, so finally we are traversing through this topological order list, right? The one which we got. So see here, we are first adding this reset, right? We create a reset. So reset.getTemp. So first of all, we are getting what all there in the reset, and then we are adding that node first. After adding that node, we are basically adding all the values which are there at the answer of node, right? Which we just explained. And after that, now you can see here, I created this res set as the list of the hash set, because we want the we don't want the duplicate value, but in our answer we have to return the list of list, right? So for that reason, in final loop, what I am doing here, I am just populating those set value into this result, right? I am creating all those value into the list of list. So after doing this, I am just finally returning this res. Okay, so this is what I have to explain, and this is topological sorting way of solving this problem. And thank you for watching the video. And any guy who is not aware of topological sorting, I have put the a link in the description box. They can watch. It is explained in Hindi language. So if that might be helpful for some of you guys. Thank you for watching the video.